The soccer team has hired an architect to renovate its stadium. There will be new lights for nighttime games suspended from new steel armatures attached to the east stands, new box seats behind a two-story frameless curtain wall to be washed from a roof-mounted suspension system, and new railings around an outdoor seating area. Who is responsible for creating the detailed versions of the following drawings? The permanent roof fall protection system anchors. So in this case, and some of you guys know more about this than I do, so you can put it on the chat, but the newer code often requires for certain buildings and maybe you can put on the chat if you know which types of buildings, it requires a permanent kind of place for a roof worker to anchor a tether. Now, this particular stadium that I'm going to show you, well, let me tell you the answer first. The answer is the contractor. The answer is the contractor. So this particular stadium where I'm going to show you, it's kind of the stadium that's, I don't know, a few blocks from here. And this whole, this was the west stands and this was already here, but everything kind of I'm circling was new. It was not that new. It was, some years ago it was new, but it was built new. And so the question is, what happens if we have roof anchors up here so that when people are above the box seats over here with the big glass, they can hook their safety tether up and hopefully not fall. Now, coincidentally, Virginia Tech, even if it's kind of required, they talk their way out of putting them on because they don't want their own employees going up on the roof. They want to hire, I don't think just because they're worried about the safety of the employees, that's part of it, but I think the bigger issue is they don't want their own employees who don't have roofing backgrounds, putting new things on roofs. Like, let's put a satellite dish on a roof for a particular, astronomy professor who needs it, and they'll put it on, but then that roof will leak forever because they penetrated the membrane. No sound. You guys hear me? Is there one person? Okay, good. Other people do see me. Okay, cool. So so they're afraid though, because roofs are really difficult. Like the occupants or even the experienced kind of handymen at the occupant level that are hired by the people who are occupying a building really are often not qualified to make any kind of even routine changes to a roof. Because it's such a specialized thing, and because roofs, unlike really anything else, roofs have to be perfect. Anyhow, so the questions we're going to look at, this first one is about these kind of anchors on the roof. Now, this particular stadium, I have to tell you that my wife was a fundraiser at Virginia Tech, and there was this thing called Ut Prosum, and that's like a motto for Virginia Tech, and it's that I may serve. And I think you had to give like $500,000 to be in this club. And because my wife was a fundraiser, she had to go, and she asked me if I would go to this banquet. And at this banquet, this is probably in 2002. And at this, maybe 2003. And at this banquet, they were honoring the people who gave a bunch of money to the university. So they started off by saying, so-and-so gave $650,000 for a new physiology lab, and everyone would clap. And so-and-so gave 1.1 million for a endowed chair of industrial engineering, and someone, everyone would clap and so forth. And this went on and on. And as you might imagine, after a while, people kind of stopped clapping because there were a lot of people giving money, and people were kind of like started talking. And then they kind of came to a crescendo at the end. And I know they purposely held this one to the end. And it said, so-and-so gave $1 million to the athletic department so that they could clad the stadium, in Hokie Stone. So Hokie Stone is this, those of you guys who are Amber Book people know that I talk about this a lot because it's a great use of kind of discussion of masonry, but Virginia Tech has its own quarry, and the quarry mines this limestone. And so the stadium is clad in this limestone, and everyone went nuts. They were all so excited about the Hokie Stone that was going to be on the stadium. I felt bad for the other for the other donors who are donating to. I'm a huge football fan, but I still think that a donation for a physiology lab is probably better than a donation for Hokie Stone. But alas, but this is pretty interesting right here that you might want to look at. What's causing this white stuff right there? Go ahead and take a minute to either put it on the chat or think about that. Yeah, it's efflorescence. So, and you see it here, and it's in all these buildings that were built on campus between about the years 1995 to 2010, and it's and you see it everywhere here. It's like when you get close, it's pretty nasty. Let's see. I think it looks like this. It's like everywhere. And this was only done 10 years ago or something like that. 15 years ago is when they completed it. They gave the money 20 years ago, but they completed it 15, if even. And so they have this staining. So what do you do when you have this staining? Well, actually, first of all, see if you can kind of sketch out what caused the staining. What's the issue? What caused the staining? Go ahead and sketch that out to yourself. So we have in section, we have the wall itself. In this case, it's concrete block, but it could be poured in place concrete, or it could be steel with a exterior rated gypsum board sheathing. Either way, and then we have outboard of that, we have our rain, air, and vapor barrier. And then outboard of that, we have our insulation. And those of you guys who have done Amber Book, you know this quite well. There are other ways to do it, but really not. You don't have as much freedom here as you might think if you want durability and thermal performance and moisture performance. So anyhow, and then we have our Hokie Stone. And this stuff is, I don't know, $400 a square foot or something. It takes forever for the crews to put on. It's very manual labor. It's the most manual labor I've ever seen on a construction site in the last 10 years. And let's say this is the ground plane. So you know what's going to happen. Ideally, when it rains, and especially if there's wind-driven rain, but even if there's not, both in the limestone and the mortar, the moisture is going to go into the cavity. And if everything goes well, it's going to drop down the cavity. And then there'll be flashing here, and there'll be weeps here. So those weeps can be, they're these little proprietary inserts they put in these days. But when they made this in the early 2000s, they used like a wick, like a rope. So there's a little rope that kind of helps wick. So if there's ever any moisture that builds up here, it'll just wick out. And actually, that flashing doesn't go in front of the insulation as they do it. It actually goes behind. It goes back in here. So that way, even if some gets behind the insulation, it'll be hopefully behind the flashing will be behind the rain, air, vapor control layer. Anyhow, if everything's going well, that's what happens. Now, if something goes wrong and moisture is somehow trapped in this airspace here, in this drainage plane, and the drainage plane, I mean, if you ever get asked, the minimum is 3/8 of an inch, but in reality, it's not quite that straightforward. It kind of depends how wet the climate is and so forth. But anyhow, and if it gets trapped back there, then when it comes back out, say it gets trapped here, say there's a bit of mortar here that gets gunked up. So when the crew is putting the mortar in, some falls back here and kind of gunks it up. Now the moisture's coming down here and it has nowhere to go. And so on a dry day, it won't stay there forever. On a dry day, it'll gradually seep its way back through. Now it's gone through the stone and masonry and mortar one time, and then back through the other time, and it's picked up a bunch of minerals. And so instead of coming out down here, it's now going to come down and stain the efflor. It's called efflorescence. Efflorescence. I think that's spelled right. Anyhow, so what they'll do is they'll put some mesh back here so that mortar doesn't get back there. They'll put like it's just, I don't know how to describe it except for it looks like I don't know, like picture a cat coughing up a fur ball and just picture a lot of that. It comes in a mat and they'll put it back there. But what's actually, well, first of all, why didn't it happen before 1995? So there's lots of Hokie stone buildings on campus going back more than 100 years, but it was never a problem really until 1995. Why would that be? Go ahead and put it on the chat. So the reason it wasn't an issue before is before our buildings were so leaky. There weren't really good membranes, so it was more of a kind of often an overlap system of like, I don't know, tar paper, building felt. And so and there certainly wasn't exterior insulation or rigid insulation. So our buildings were not airtight. They were not watertight. They were not thermally tight. And so there was so much energy flow going from the inside of the building to the outside of the building and back, depending on the season, that if there was water trapped in here, it would typically drain to the inside, because it was just all kinds of heat and air going through. But beginning around 1995, our buildings started becoming much more airtight, much more watertight. And so the water wasn't allowed to kind of go into the building and just dry out. The water had to sit there and then come back out the other way. That's why it didn't happen before then. Now, when you have, this is the flashing at the base, like we showed you. And here's one of those wicks. So here's the flashing and here's the weep. But when you have all this Hokie stone and it goes up many, many floors, I don't have a photo of it, but the Hokie stone itself is pretty heavy and it's not super structural. And so every once in a while, there's actually a ledge. This isn't the only problem, but it's by far the biggest problem. There's a steel angle. So if we go back to here, every once in a while, there's a steel angle that's tied back to the structure, and it holds the next, floor and a half or so of Hokie stone above it. And the problem with this is we were putting the steel angles in, and we were putting the flashing and weeps at the bottom, but we almost never were putting them in at lintels where the steel angle went above a window, or at just the kind of steel angle that we needed to support the Hokie stone, because the reinforced concrete block is a lot stronger and can hold it up, but the Hokie stone itself will collapse under its own weight. So when the moisture came back through here and went down, there were no weeps. Now there are. In fact, normally you would have the architect making the detailed drawings for this, and the university hires architects, but the university has its own detailed drawings that have to be adhered very closely for this because of the efflorescence issues. And so the moisture builds up in here, if you can see where I'm kind of drawing here, and then it comes out here and then stains down. And so that's why we're seeing the staining. And so what they've had to do, they've been going through campus the last 5 years, and all the buildings built during that era, they're, great expense and time. This project is still going on. I saw it this morning. It's been going on since right after the end of football season. So it's been, 2 football seasons ago. So it's been like a year. It's been like a year and a half or something. And so this is an older photo from several months ago, but anyhow, they're taking off the Hokie stone. I think they're writing down where the Hokie, because they manually chip it into place. So I think they probably are mapping where each one goes and cataloging each one. But you see all the kind of work here and here. They came all the way down to that black stuff is the rain air vapor control layer. And here they are working, and here it is again, and here it is again, and there it is again. These are all the anchors. Those anchors, the way they work is there's different ways to do it, but there's like a little kind of loop here, and there's like a candy cane that goes in the loop, and then there's a little tab that comes off the candy cane. And so the idea is that it's all steel, all stainless steel. That tabs has some tolerance, can move up and down on that candy cane, and it looks like just a stainless steel candy cane that's much longer than a candy cane, and it can move up and down, and it can sit in the mortar, and it can help with the flexural kind of the idea that the stone wants to pull away from the building. So here it is, also kind of stripped down. Here it is from above, looking at him. So they're kind of taking it out one by one. I actually was watching them do it there. There was a guy who was more experienced. he was doing it no problem. There was another guy who was having trouble, and the guy who was more experienced was having to, jackhammer the mortar out for the guy who was less experienced, because they really don't want to. They have to be careful. They don't want to puncture the rain, air, vapor control layer, because that kind of ruins the point of the rain, air, vapor control layer. But you can see the kind of, almost kind of really cool corbelling detail. It's not meant to be corbelling detail. It's just the way that the corners are meant to be, where A overlaps B and then B overlaps A in terms of the two planes. But anyhow, super complicated stuff. Now, this is the lighting that they put on a little bit before then. That's huge. That's probably, each one of these is a row, right? So that must be like, I don't know, 40 feet tall. And believe it or not, the lighting is these big steel armatures. And I live in a very windy area of the country, and that lighting is obviously very heavy. So it's a steel. And that lighting is all glued on. No smack. I'm not joking. It's actually glued on. In other words, they had the existing stands. They added the lighting before. This is, in the 90s, but or maybe early 2000s. But they added the lighting for night games, and what they do is they have the steel plate that's welded to the steel armature, and they have the existing concrete of the stands, the top of the stands, that then slopes down in section. And you would think they just bolt in, but they don't. They drill an extra big hole, much bigger than the bolt, and then they put the bolt through it like that. And then, but it's just loose in there, and then they fill it with an epoxy. So it's just glue. It's chemistry, and it holds. It's amazing, the stuff that we have. It is absolutely amazing. And of course, they have railings, and these railings are not what you think. I mean, generally, if you were in school. If you're in school, you think the architect designs these, but actually these types of things, a lot of these things are shopped for. Basically, they're systems, and there's existing hardware that's been tested for a bunch of 300-pound, dudes getting excited about a football game, and they want to make sure it doesn't tip over. And so in the little seating areas and stuff, when they put the railings in, the architect will design what the elevation of the railings looks like. But really, the architect is not, it's more multiple choice than an essay question. Like the architect has, in practice, of course, in theory, we can make a custom railing for everything. But typically there are systems, and the architect is more or less a shopper. And of course, you want, and if you're taking the exam, you definitely want to know that if you're ever asked about what kind of specs you want for a railing like this, you want performance-based specs or something of the like. You do not want proprietary-based specs, because proprietary-based specs says, oh, we have to use this particular railing system. And the problem with using this particular railing system is that it's a state job. If the state will get fleeced, because the people who do that railing system will say, yeah, that'll cost $600,000. And the contractor will say, seriously? And they'll say, yeah. And the state will have to pay for it because it has to be that railing system. Well, we don't really allow that. Almost no municipalities do. And most owners don't want that either. They don't want the contractor, when she's negotiating with a vendor like a railing fabricator, they don't want the railing fabricator to know that you have to use that particular railing because it's in the specs and it was agreed to. It's in the contract. So, and then here you see the big glass, and so we have to somehow clean that glass. It's this frameless glass. It's several stories tall or a couple stories tall, and it allows for you to see the It allows you to see the game uninterrupted by, then it has to be really clean, right? You don't want to see a bunch of schmutz on the glass when you're trying to watch the game. So there's the railing again. Here's just a view from, I think I took this morning. I did. And there's the workers kind of, taking the hokey stone. I guess maybe they're not cataloging it. That doesn't look so cataloged. Maybe they're putting a number on it. It sounds like a horrible job, really, just super frustrating. Anyhow, there's those lights. So these are the lights that are glued on. And this was at graduation last year. I took a photo when they were starting to fill up. So back to our question. The question is, who makes the detailed drawings? And the most important thing to know is the word detailed versions of the drawings. Is it the architect? No, the architect does not, because you don't want an architect to have to figure out what type of hardware keeps 4 300-pound guys who are leaning on the railing during a football game, jumping up and down, from busting the railing. Believe me, none of us want us doing that. You want railing people doing that, people who are making railings all day long, who know the performance of railings and the type of steel and the weather and so forth. So you don't want the architect doing it. The structural engineer won't be doing it either, for the same reason. They just don't know as much about railings as the railing supplier, this railing systems manufacturer. So it's a company. It's Smith Railing Company or whatever, and they're going to do it. Now that's not on here. The manufacturer is not on here as an option, but the manufacturer is going to make it for the contractor, and by the contract. And as far as the architect and the owner are concerned, it's the contractor who's responsible for it, even if the contractor has a subcontractor who's actually going to be making the shop drawings. Those shop drawings with things like mock-ups of walls and that kind of thing, and samples, those are called submittals, and those are given by the contractor to the architect, and the architect has to approve them. So the contractor will give in this case, the permanent roof fall protection system anchor manufacturer shop drawings to the architect. The company who's making it, Smith roof fall protection anchors, is going to give it to the contractor. The contractor is going to give it to the architect. So as far as the architect is concerned, it's the contractor who's responsible for it. And the architect is going to approve it, hopefully quickly, because they're waiting for you to approve it. Often you won't do it quickly, but you should. But you don't have, the good news is you don't have to check the bolts to make sure that they can hold 4 300-pound guys. That's not your job. Your job is just to make sure that the design intent, you don't have to go out there and measure and make sure their railings are the exact measurement to the inch that the width of the, I know we're talking about roof fall protection systems, but you don't have to go, the architect doesn't have to go measure to the inch to make sure that the shop drawings, match what's been poured in the field, poured concrete that's in the field. The architect then gives it to the structural engineer, and the structural engineer might actually do some calculations to make sure that that in this case, the anchors on the roof actually are enough to hold. And then the structural engineer gives it back to the architect and says, yep, looks good to me. And the architect gives it back to the contractor. So it goes subcontractor, to contractor, to architect, to consultant, back to architect, back to contractor. If that seems inefficient, it is, but it's redundant on purpose. It's redundant in the same way that if you go and invade a country, you want to have more forces than you need. You want everyone to know what's going on so that if there is a problem, maybe the railing is super ugly, or maybe, and the architect needs to say, that's not the quality of railing I wanted. And look at the specs, it's not equivalent to what I had drawn. Maybe the structural engineer says, that's not an acceptable thing to bolt into. You think you're bolting into the concrete block, but that concrete block is not reinforced concrete block. So you can't bolt that railing into it. You just don't know that railing manufacturer because you're not as familiar with the building. So we want everyone to look at it and approve it, because if there is a problem, we want more eyes on it rather than fewer. And so the answer, of course, is contractor. Now let's do another one. I think I already kind of answered it for you. But who's going to be responsible for the railings? Well, again, it's going to be this. In this case, it's going to be the same thing. It's the contractor. So the contractor is going to come up with the drawings from the sub. The contractor gives it to the architect. The architect gives it to the structural engineer. The structural engineer gives it back to the architect, and the architect gives it to the contractor. It seems convoluted, but it kind of has its own logic. And so the trick is if you see the word detailed in the exam, it's going to be the contractor or the subcontractor who's responsible for it, not the architect and not the structural engineer or the architect's consultant. Typically, if it's something that if it's detailed and it's something that gets fabricated in the field, like a railing, like an anchor system. All right. Now, let's do another one. Okay, here's a railing system. This is actually inside the stadium. So this is a different, nicer railing system. But these are the kind of things that are mass produced by a railing manufacturer. They're not typically custom made for your particular building. So you can get nicer. These are nicer. There's the thing. But again, you don't want the architect and the structural engineer each time to have to look at the ASTM standards for railings. That's not necessary. All right, this is for a roof. Now we're going to do the same thing, same question, but for a roof-mounted window washing track. And so we have to wash the windows, those giant glass windows. And actually, I had a student named Charlie who worked during the summers, and he was putting in a window, and because it was super tempered, because they were trying to jam it in and it wasn't quite fitting, it broke, and the glass went all the way across the stadium onto the field because of the embodied energy in the tempering process. More on that in another 40 minutes of confidence. But anyhow, sometimes needs to be a track, and that's what we're talking about. And so the question is, who is responsible for the detailed versions of the drawings of the roof-mounted window washing track? Go ahead and take 10 seconds to answer. Yeah, it's the contractor, because it's detailed and it's either manufactured or fabricated, and it's life safety. We don't want the architect, even with the help of the structural engineer, coming up with their new version of a window washing track when the window washing track company has decades of experience knowing which ones have ball bearings that rust and so forth. All right, let's do another one. The steel frames for the lights. Who's going to make the detailed drawings for those? Go ahead, and you can take 10 seconds to answer. Yeah, there's still going to be shop drawings. If you're asked for detailed drawings are going to be shop. Now, of course, the structural engineer is going to make detailed drawings, but I'm telling you, on this exam, if you're asked detailed drawings, they're trying to get you to understand that the architect and her consultants are not responsible for those. So the NCARB really has an agenda. They're trying to get you to understand that you as the architect are not responsible. But of course, the structural engineer will be making some detailed drawings for the steel frame, but not the most detailed drawings. Those are going to be done as shop drawings, which are under the category of submittals. All right, I have time for some questions. I have time for 4 questions if we have 4.
So just for sakes of keeping everything in my mind correct. Mm-hmm. So the question is really asking about who gives the shop drawings, or who procures the shop drawings, because the contractor doesn't really draw them. He hires someone, or he asks the factory to provide the shop drawings, and then he gives them to the architect. But with that, first comes the fact that the architect probably in the specifications, with the help probably of the structural engineer, or depending on whichever item we are detailing, he probably wrote a scope about a performance specification or something that then the contractor used in order to find the specific item and order those shop drawings, correct?
Yes. So what happens is the contractor then, so that the specs, which are really kind of the fine print of the building, the specs will say something like, railing shall meet ASTM. I'm making up these numbers, but ASTM is American Society of Testings and Materials. 5914.2 performance of outdoor railings in rainy climates, right? And so I'll say, and it shall also meet the specs of, of whatever point, whatever, ISO 4115. So this is what I mean by performance-based specs.
Yes.
So if you get a question about a specs, you want to use performance-based specs. There are other words for it that they'll use, but you don't want proprietary specs, especially closed proprietary. So open proprietary specs can say something like Smith Railing Company or equivalent. That's open proprietary specs. Those are better than closed, but still not great. But performance based specs are what we want generally. So the contractor then will actually, right. So the contractor will actually, will bid it out between 3 different railing manufacturers and then typically go with the lowest price. And sometimes the contractor will say, I really can save the owner a lot of money if I go with my buddy he's great too, and he does really good work, but but his don't meet these particular performance criteria, but let me see if I can talk the owner and the architect into it. And the contractor usually during the bidding process will ask for a substitution permission. And if you, the architect, give it, you have to give it to everybody because everyone has to be able to bid on the same thing. If you say, oh yeah, we're okay with that type of railing, instead of, if you want to do it instead of galvanized metal steel, you want to do it in stainless steel, which is typically more expensive. That's fine with us. Go ahead, go for it. And we'll let everyone else know who's bidding that they also can do it in stainless steel if they wish to. In a small job, the contractor may do the shop drawings. I mean, it's not typical, but it wouldn't be unheard of for the contractor to have their own metal shop.
I didn't know that.
And so it's not, typically it'll be a subcontractor, but as far as the architect's concerned, it's the contractor, in the same way that if you went to the coffee shop and you got a cup, they gave you a cup of coffee and it had a hole in it, would you say, oh my gosh, your manufacturer of cups gave you a cup with a hole in it? You'd say no. You'd say, Starbucks, you gave me a cup with a hole in it. In the same way, that's so yes, you're saying, well, how come subcontractors not on there? Because as far as the architect is concerned, it's the coffee shop, not the cup manufacturers. Of course, there's upstream of there's other people, but as far as the architect and the contracts are concerned,
I would say like the manufacturer was like the most correct option, because manufacturers are the one that create the specs. Even like if we are trying to say that detailed version is like all the most detailed version of everything, it has to be the one that comes from the manufacturer, which are the shop drawings. Because I was also like trying to understanding first when you said detail, I went to specifications. So specifications could be done by structural engineers as well, from consultants from the architect or even consultant from the contractor. But you are saying that when I see detail, it's like a code for specs.
For contractor. Yeah, it's a code for specs. If it's something that's fabricated, and if you don't see subcontractor, which you often won't, it's the contractor who you would pick. And so the idea is you're picking the best answer. And so maybe it would have been better if I said, instead of, who's responsible for creating, if I just said, who is responsible for the detailed versions instead of creating. That may be a little bit better, because then...
Not sure. Yes.
Well, if you said procuring, you would know it's not the architect or the structural engineer.
Okay.
That would give it away, right?
It's tricky. It's tricky to find the word.
Right, exactly.
Thank you, Michael. So nice.
You're welcome. All right, I have time for one more question if we have one. It says architect is not responsible for detailed drawings, not according to NCARB and the contracts. The detailed drawings of things like that are not going to be from the architect. Now, who decides what a detail is? That's a little bit more fuzzy, right? So really the best answer is contractor, but sure, the architect with help from the structural engineer are going to do all kinds of details. They may want to show that there's a space between the railing and the ground because they don't want water to build up. If the patio is here, they want to show that this gets mounted here the railing gets mounted there so that water that builds up on the patio is allowed to run off without getting trapped on, on some, otherwise if you did a railing that was like this, maybe there'd be water built up. So there are lots of reasons that the architect may want to detail, or the structural engineer may want to detail the railing. But if you're asked the detailed versions of the drawings, the answer is we're talking about shop drawings. Natalie, this is our last question. Go for it.
Hey, Michael. Thank you for the class. I understand that the architect basically just does like a simple call out or design intent. So the answer to the question would be the contractor or the structural engineer. But how do you decipher which of the two?
So if you're not sure and you see detailed, it's the contractor. So okay. The structural, if it's detailed, that's kind of the purpose of this 40 minutes. If you take nothing else, if you understand about how a wall is assembled, which is really important, and you understand kind of the other stuff I was talking about, the most important thing you can take away from this is that if you are asked about detailed, it's the contractor. And I think, frankly, I think that I think NCARB has a mission, and that is to help architects. Frankly, I think I don't know that, but I think that there's a lot of stuff in NCARB where basically they're asking things like, should an architect charge extra for this? And the answer is almost always yes. So they're giving us more money, right? And there's also a lot of questions where is the architect responsible for this? And it's often no. And and we kind of think we're responsible for it, but we're really not. We're responsible for design intent. Our responsibility is actually much more limited than you would think. Now, there are architects who go all the way down the rabbit hole in this stuff, right? So, I've seen houses that were built with 4 or 5 sheets of paper. I've seen houses that are built with 200 or 300 sheets of paper. Houses of comparable size. So it is not a one size fits all, but what NCARB is trying to get you to understand is that contractually, you don't have to go as far down the rabbit hole as some of us do go. Now, I happen to think as someone who, I think, someone who teaches studio every semester and has for 20 years, my real true love is design. I happen to think that the architect is better equipped to make something beautiful than the fabricator. And so I think that the architect should be working with the structural engineer on these things. I mean, of course, roof anchors for safety are a little bit of a different issue, but anything that's going to be visible, especially something that's as visible as railings, and is important to an elevation as railings, and elevation, I think, is one of the most important, if not the most important kind of aesthetic. I think that the architect should get as detailed as the architect can within the practical constraints that generally architects are a little bit more shoppers, choosing multiple choice in that situation than you might think.
So from the list of responses, like I think there was like 4 options. Was any of them the structural engineer, or they were all contractor?
They were all the contractor. It was kind of a trick question. They're just contractor.
Okay, cool.
The word detailed. The end. If it's detailed, the answer is contractor. Unless you have a really good reason to think it's the structural engineer. But I can't imagine. If it's not, like, for instance, I'm trying to think of an example. Maybe you guys can on the chat, an example of where the structural engineer would make the most detailed drawing. But in reality,
I thought maybe the steel frames for the lights was the structural engineer, because it would have to be like structurally sound.
It is. And the structural engineer surely on the lights is going to call out the thickness of the structural elements. They're going to call out the geometry of them, because that's not a fabricator's job. But in terms
NCARB
of
basically says detailed as shop drawings. That's what detailed means in the NCARB
and the
world.
structural engineer may call out the welds, but often won't. The structural engineer knows what kind of the climate it is and will call out welds. And then the fabricator will call out the welds and the bolt sizes and that kind of thing, perhaps. And then the structural engineer will look over them and often do calculations to make sure they're not going to shear off. I won't walk. That's an exaggeration. I often won't walk underneath those lights, knowing that they're glued on. I just don't like to be underneath those lights. I'll walk a little bit to the right where I'm under the overpass because I just
Yeah, I
don't
do the
trust
same
glue.
thing with like potholes and stuff.
Yeah, I just don't trust glue.
Mhm.
So, all right, guys. Good night.
Thank you so
Get
much.
licensed.